Sure, I'm Nick Blouin, the Surf Fellow for September at the Sitka Sound Science Center, and I'm a phycologist, which is somebody who studies seaweeds, or the algae in a broad sense. And mostly what I study are marine macroalgae and how they interact to create their ecological niche within that environment. I originally got into to study phycology because I was interested in the beauty of the seaweeds and their economic importance. Along with that comes ecological importance. I've worked on primarily reds at this point, but I've begun to, in my parasitic work, I've begun to look at some green algae as well because they have a different mode of infection for what they do. And in fact, I suppose what led me to that is there are a lot of parasitic organisms that used to be algae. For instance, malaria used to be an alga a long time ago. So I can look at the genomic complement or the gene complement of the parasite and the host and look for things that are either missing or have been gained in the parasite and make inferences or begin to understand what those first steps are towards parasitism. And if you think about, the systems are not analogous, but if you think about malaria as being a parasite that's at the top of the staircase, it's been a parasite for quite a long time, at least in evolutionary steps. Highly evolved, very complex, but we know was a photosynthetic organism at one point. And if you think about the red algal parasites, I would argue that they are in these first couple steps, right when you leave the floor, starting up that staircase. And we can ask ourselves, if we know what the end is likely to be, and we know there are certain things that have to happen, which include losing the ability to photosynthesize and start scavenging nutrients, by looking at these closely related neighbors, we can get a sense of what that evolutionary trajectory is. And why is that important, or why that is important, is because from that we can gain an understanding of perhaps future drug targets by understanding how the genome has dismantled itself or augmented itself over time. We can get an idea of whether or not we think a new parasitism over a long period of time, and of course this is over evolutionary time, is going to become a problem or not. This is fascinating in terms of comparative evolutionary genomics to me. I guess when it comes to the intertidal zone, the thing I like being out there most is that often, at least where I collect and when I collect, nobody else is around. And it's a place where, especially coming from the East Coast, where there are frequently people in almost any environment, it's one of the few places where you can really expand your mind across a larger space and feel that. And so when I'm out there collecting seaweeds for whatever project I'm working on, the sounds of, for us, it's, at least in the wintertime, it's loons before they start moving offshore. And frequently where I collect are in high energy environments, meaning areas where there is lots of surf, crashing waves. The sound of that water moving around and the rhythm of that, I find really quite peaceful. And I'm happy to poke around for as long as possible in the intertidal zone at that point. It's a really terrific experience.